Hello, welcome to this lesson of our study of vectors. Okay, so in this lesson we'll go through how to solve simple examples on vector cross product. Okay, or in simple put like vector products. Okay, of two vectors. So if you have not subscribed to the channel, kindly subscribe to support the channel. Okay, all right, let's start. So in this question, first question we have find find this one, which means the magnitude of A cross B if A is given as this and B is also given as that. Okay, so the moment you see the two bars like that, this and this, then it means magnitude. Okay, all right, so let's start. So to solve this, what you need is the definition of cross products. Okay, so all that we need to find is first find A cross B. Okay, and we know that A is given us 2I plus J plus 3K, and B is giving us 3I plus 5J minus 2K. Okay, so with what we just learned, A cross B would then be equal to the how do you call it, the determinant of I, J, K. Then first of all you write A, the element of A like that. Okay, then 3 5 that of B. Okay, now we said this will be equal to, so we have A cross B to be equal to I J K like that, and we have A to be 2 1 3 and B to be 3 5 negative 2. Okay, so I'm using this method to solve this for the first question, and then the remaining questions I'll be using the shortcut method. Okay, so this you just find, you said that you just stand on this one, stand on the first element, so you cancel these ones and these ones, and the remaining matrix you take the determinant of it. Okay, so the remaining will be 1 3 5 negative 2. Okay, determinant of that, then I, then minus, you come on this one, the second entry, that the second element in the first row, that is the J, and you cross that one as well and this one, so the remaining elements you take them as well. Okay, so you'll be left with 2 3 3 negative 2, then J. Okay, then plus, you know how you go about it, you go to the last one, and that one too, you'll be left with 2 1 3 5. Okay, then K. Okay, so now how to find determinant. Now this will be equal to this multiplied by that minus this go to that. Okay, so simply negative 2 minus 3 times 5, which is 15. Okay, I, then minus negative 4 minus 9. Okay, J, then plus 10 minus 3K. Okay, this will be negative 17 I plus how do I call it, 13 J and plus 7K. Okay, I hope you understand this. Okay, so this is very very simple like that. Okay, but let's look at the shortcut method. Now with the shortcut method, you know your A to be this. I'm teaching this because I'll be using that a lot. Okay, this 2I plus J plus 3K, and my B to be equal to 3I plus 5J minus 2K. Right, now with the shortcut method, what we just said is that A cross B would then be equal to, first of all you write the elements of the first vector from the J component, so you write 1 3 like that, then you come to 2, then you end at where you started. Okay, the second vector you write from the J component, which is 5, you go to the K, which is negative 2, come to I, which is 3, then come to the 5 again. So now this whole thing would then be equal to, very simple like that, this times that minus that, okay? So negative 2 times 1, which is negative 2, minus 5 times 3, which is 15. So negative 2 minus 15, that will give you negative 17 I. Then plus, this time you say you add, you don't subtract, okay? So plus, and 3 times 3, which is 9, minus negative 2 times that. So 3 times 3, which is 9, minus negative 4, and that will be 13, okay? J, okay? Then you come to this, alright, and this. So that one to 2 times 5, which is 10, minus 3 times 1, which is 3. So we get what? Plus 7k. I hope this is very simple. So this is how it goes. Like, it comes to this side like that. So all of them, this comes to this place, then minus this goes to that place, like that. This comes to that place, then minus that, and this one to minus that. Okay, that's how you go about it, and that will be it. So now the main question is for us to find the magnitude of A cross B, and that will be equal to square root of negative 17 squared plus 13 squared plus 7 squared. Okay, square root of the whole of that, and I will get the answer to be square root of 507 units. Okay, I hope you get this. So this is very simple like that. Now let's take a look at the different type of questions that we have here. Now find the area of a triangle having points A, which is that, and B, which is that. Okay, so if you remember, we said you can extend the application of cross product to area of a triangle. Now this, for this question, you need to analyze it very carefully, because the vertices have been given, but we don't know how to use the vertices to solve area of a triangle, but we know how to use the vectors of the adjacent sides of a triangle to solve the area. Okay, if you remember, we said, sorry, let me draw it well so that you can appreciate it well. Okay, so if you remember, we said that the vectors are supposed to be, let's say if this is A, this is my B, and this is C, then for us to use a triangle formula, then the vectors are supposed to be represented on the two sides of a triangle like this, okay, of which all of them will be moving from the same point. Okay, so if you know the vectors along this side and along this side, then you can find the area of the triangle using the formula we just did in our first discussion. Okay, so now, but we know the point position vectors, or the points of both A, B, and C. Okay, so A is 1, 1, 1. You know B to be 1, 2, 3, and C to be 2, 3, and 1. Okay, so with this one, all you can do is you're supposed to find this vector AB, okay, and vector AC, because these are the vectors we need to find the area. Okay, then what we can do here is that we have to, vector AB will simply be equal to, from all we know, is the same as OB minus OA, and this is the same as like subtracting the points. Okay, so OB in terms of position vector is the same as B was given as 1, 2, 3, and in Cartesian coordinates I plus 2j, okay, plus 3k. Okay, I hope you get this. Now minus, then A is 1, 1, 1, so like that. Okay, so the negative is affecting every, so 1 minus 1, that is 1i minus 1i, I'll get 0i. Okay, is it 0i? Yes, then plus j and plus 2k. Okay, now my AC will be equal to OC minus OA. We just discussed this in one of our lessons, so I hope you understand this. Now OC is also giving us 2i plus 3j plus k. Okay, now minus I plus j plus k. Okay, plus k, like that. So everything will be I plus 2j plus 0k. I hope you get this. Now the area of a triangle was written as area is equal to 1 over 2 times the magnitude of A cross B, from our lesson, where the A and B are the vectors along the two sides of a triangle, and the two sides of a triangle in this sense, or in this category, is this one, AB vector AB and vector AC. Okay, so what I can do here is that this is the same as in our context here, this vector AB cross vector AC. Okay, I hope you get this. So I have to just find AB cross AC. We know that AB is giving us where's my AB? My AB is 0I. The reason why I'm maintaining the 0 is for the cross product to be easier for us, plus J and plus 2K. Then our AC is also giving us I plus 2J plus 0K. Okay, so AB cross AC, we need this, okay, will be equal to simply writing my AB from the second term, that is the J term, and I'll get 1, 2, 0, then 1, okay. And I come to AC, I just write it from 2, 0, 1, 2, okay. So like we do it always, this goes to that minus this goes to that, okay. So 1 times 0 is 0, minus 2 times 2, which is 4, and that will be 0 minus 4, that will give you negative 4I, okay, and plus 2 times 1, which is 2 minus 0, and that will be 2j, and plus, okay, 0 times 2, which is 0 minus 1, that will be negative k. Let me put it that way, and that is A cross B. Now, sorry, AB cross AC. Now the actual area is, we need the magnitude of this. Okay, so magnitude of AB cross AC, okay, will be equal to the square root of negative 4 squared plus 2 squared plus negative 1 squared, okay, and that will be equal to the square root of let me see, what do I have here? I have square root of 21, okay. I don't know, you have to go through it, and I believe this is right. Now the actual area is this. A is equal to half magnitude of AC, or AB cross AC. Please don't go and use it, or don't go and interchange them like AC cross AB. That one will give you a different solution altogether. So the area is equal to half times square root of 21. Then this is the solution. So it's 1 over 2 square root of 21 squared units. Okay, squared units. I hope you understand that. Okay, so that is it. Now let's go to the next question. The next question is, find the area of a parallelogram whose adjacent sides are given by the vector is this. So the parallelogram is having adjacent sides to be this. Now this question is very easier because for us, we know that the area of a parallelogram given the adjacent sides, we know how to find the area. Okay, we know the formula for the area, so all we can do is just code the formula. The formula is saying that area should be equal to the magnitude of A cross B. Okay, now I know my A to be giving us 3I plus J plus 4K. Okay, my B to be equal to I minus J plus K. Now with this, all that I'll have to do is just go and find A cross B, then I'll use whatever I know. Okay, so I know my A cross B. All that I have to do is just write A from the second term, that is the jth term. So I have 1. Okay, I believe you have it with you, so you'll be able to do this. Okay, then for the B, I have negative 1 to be the jth term. Then I have 1 to be the k term, 1 to be the I term, and the negative 1 again. Okay, so like that, this goes to that. Okay, so 1 times 1 minus negative 4, and that will be 1 minus minus 4, that will be 5I. Okay, then plus 4 minus 3, which is will give me j. Okay, then minus, because I have negative 3 minus 1, that will be negative 4k. Okay, so now my area will be equal to the magnitude of a cross b. Okay, and magnitude of a cross b is the square root of 42. Okay, and squared units. Okay, squared units, that is what you should know about. All right, so these are the few examples I have for you on a cross product. Thank you, and don't forget to subscribe to the channel. I see you next time.